I'm going to speak about, management of the chain and economic issues in relation to coexistence. The purpose of coexistence is to secure the consumer's free choice, but on the other hand also to set up a system for the producers in the chain to have a free choice. The economic optimization will be on a case-to-case basis. There's no way that we can design one route to all supply chain systems saying this is the optimal way of doing things for coexistence purposes. It will always depend on the company, the product, the country. But of course there will be similarities within the supply chains. And we can say the further you are, the more vertical integrated a chain is, the more simple or easy it is to conduct coexistence. There's a number of management strategies that they could go for. And the first one is, of course, segregation, where you dedicate one factory or one processing unit to DM and one to non-DM. You could also have spatial specialization, which means that you have two lines or you have more lines within one processing unit and you dedicate one line to either DM or non-DM. And then you have the third one, which is temporal specialization, where you run DM, clean, run non-DM, clean on DM. So you use the same line for both productions. And if we take the temporal segregation, the strategy is to clean the production line prior to non-DM production, because now we are looking for which strategy is the cheapest or the most cost efficient. And that, of course, will be to clean before you have a non-DM production, because then you can save cleaning after. You don't need to clean from switching from the non-DM to the DM production. And you have, of course, some prerequisites in order to handle the temporal specialization. And as a minimum, you need 2 input silos, one for DM and one for non-DM. And then the strength of it is that it's extremely flexible in the sense that you can always do your production according to the demands for the different products, whether DM is in demand or non-DM is in demand. And there's no cost to overproduction in the sense that you can always adjust your production to the demand. And then there's a modest need for investments.
Process. So what we identified is total cost reservations from people, which is the same as an elevator.
There were several software developed for instance, the subsampling optimization, integrating a cost function, and as already said by Guy van den Eede from the GRC, the cost will be an important part because we are multiplying by changing our paradigm in GMO detection from quantitative real-time PCR to subsampling and detection qualitative method. Those we were able to determine one of the reasons for which the stakeholders were using a threshold, a practical contractual threshold below the labeling threshold, and one of those the results was by working on the results of the GRC CRL studies. We observed that there is a factor 2 of safety between the labeling threshold and the practical contractual threshold. And it is a very usual method, very usual safety margin companies are using in several other areas where detection is involved. Then we were working on several ways to assess and easily implement in the labs, which are generally accredited, the validated method, most of them being validated by the JRC CRL. We were working on the variability of the globally used modular approach, a concept which was developed by Aaron Hodgson in the qPCR GMO food project and of the FP5, and it was very important to work on because this modular approach is used in all the European validation and is used more and more in several other detection areas about pathogens, about mycotoxin organism producing, etc., etc. So it means it's not restricted to GMO detection. It is a quite a global approach, and because it is less expensive, it is more flexible, etc., etc. But we had to assess the overall measurement uncertainty. We compare several chemistries and apparatus used for implementing this CRL validated method, and now there is a better flexibility and the lab school in front of the accreditation bodies show that most of they will have papers to show that it is quite easy and it is understandable to move from a chemistry used for a validation to another one, which could be, for instance, less expensive or provide a shorter duration of analysis, etc., etc. And we worked also on how to improve the reliability and to decrease the sensitivity of our detection methods to, for instance, PCR inhibitors, etc. So this, we have several methods now which are less sensitive to inhibitors. We have some methods that are working in the cooperatives. I will not say in the fields because generally the analysis except some protein-based methods are not used in the fields, but at least in the cooperative based on PCR or LAMP, etc. We have methods that are at least 100 times more sensitive, and we can improve that. It's only depending on the cost you are ready to pay for that. We were combining a lot of DNA amplification method with statistical methodologies, with microarray, etc. And we are able at this moment to detect numerous targets in one tube.
CoExtra also has developed new detection strategies which, for example, address stacked or unapproved GMOs. Due to the large number of questions CoExtra faced, a decision support system was developed to integrate such data and to facilitate their use by stakeholders, including laboratory analysts.